Hello and welcome. Good morning for our friends in the US, good afternoon for our friends in Europe, and good evening for our listeners in Asia. My name is Willy Fabricius, and I'm a global head for strategy and business development here at SGS in the Business Assurance Division. And I'm delighted to start today's conversation about robustness and performance of AI applications with my friends and colleagues, Tomislav and Sebastian. Tomislav, want to go ahead and introduce yourself, please?
Thank you very much, and hi everyone, hi to all listeners. So I'm Tomislav. I'm working for SGS as a lead innovation technologist, and my role is basically to look into emerging technologies and determine what their impact on our business and the businesses of our customers is. And for 2 years now, my main focus topic is artificial intelligence and everything around that concerning the trustworthiness of AI systems. My background, I was working before I was focusing on the AI system 15 years in cybersecurity, so I have some expertise in this area as well.
Thank you, Tomislav. Sebastian.
Yes, so I am Sebastian. I'm a senior researcher at No Center, which is an AI research center in Graz in Austria. And so my background is I'm a physicist, but now for many years I have been working in AI, and again, I do two main things. One is applying AI in a wide range of different projects and domains, ranging from wind power to analyzing climate data and all kinds of different stuff. And now for roughly 3 years, I have also been working a lot on doing research on certifying AI applications.
Wow, this is very interesting. And gentlemen, thank you very much for the introduction. Without further ado, please allow me to also introduce a little bit about SGS. So in the interest of full disclosure, I cannot speak French, but it's Société Générale Surveillance. And we are the world's largest test, inspection, and certification company. We have about 99,600 people globally. We are headquartered in Geneva, Switzerland. And when I say test inspection, we test things. And I intentionally use that word things because it could be literally the fabric on the clothes you are wearing. It could be testing semiconductors on the silicon level. It could be food, and it could be chips, the chips you eat. We were originally founded as a grain inspection authority, inspecting grain transported or exported from France to England way back. And yes, food safety is still one of our major business activities. However, with times changes, we have obviously adapted. And now we are also very much interested in not just using AI internally, but also offering our clients assessment services where we verify the implementation of management systems, for example, to ISO 42001, or whether we are testing and maybe inspecting, for lack of a better word, AI applications. So that said, a couple of questions for Tomislav and then obviously Sebastian as well. And please, guys, feel free to answer both the questions. You know, it's more about a dialogue rather than a presentation kind of thing. So when we are talking about robustness and performance, there's also the concept of fairness. How does this come together?
Sebastian, you want to start, or?
Yes, of course. So that's a good question, and these two things are, of course, very strongly connected. Maybe as a starting point, so fairness is a kind of a bit a specific issue. It's a very important one, but it's obviously one that's is only relevant in certain applications, and therefore also in certain AI applications. And robustness and especially performance. For me, this is kind of that's the core of every AI application. It's kind of it's not the only important thing, but it's the one thing that is always important. But what is very important to realize, if you have an application or in a domain where fairness is an issue, then these two things are always interconnected, and very often they are also there are a lot of trade-offs. So one of the most important things, if you have to deal with fairness issues, that very often you will have this trade-off between having like a very fair application or a fair outcome, and then kind of a very performant or robust one.
So basically that means, right, if you implement methods to ensure a fair outcome of an AI system, basically you often have to sacrifice a little bit of a performance, right?
Yes, exactly.
So when you guys talk about performance, sorry for interrupting, when you guys talk about performance, do you mean something like speed to answer, speed to identify, or what do you mean by that, performance?
That's a very good point, because and I think that's like, it's not talking about terms, and that's something that I like experience very often, that in different fields and also like in different technicality levels, terms can be very different. So what we mean here is not the performance, for example, of speed, but it's in how, and now I will on purpose use the word accurate, kind of how accurate our system is. But then we have the same problem that also accurate is a term that I sometimes try to avoid, because in a technical setting, it's kind of a very specific definition of performance. But maybe in more general terms, what we mean here with performance is kind of how good kind of the predictions or the outcomes of our AI systems are, which of course does not mean that for many AI applications, the speed you generate them is also important, but this is not what kind of today we will talk about if we talk about performance. It's kind of how good the predictions are. And in some contexts, good can mean how accurate they are. And in everyday speech, we probably would mostly use the term accurate, but then we run into the problem that kind of accurate, and especially the word accuracy, is also like a technical term that has a very precise meaning, which sometimes we want, but sometimes we kind of need a different measure of how good our predictions are.
So would it then be similar to something like reliability and repeatability? So if a system is reliable, as in I show it a picture of a tree and it says, well, it's a cat, then of course it's not accurate, but it's also not reliable, because, well, then I cannot trust it, right? But if I show it a picture of a tree and it says it's a tree, and maybe even the subgenre, what kind of tree, then it's reliable, then I can trust it. And if I do that now 1,000 times, and out of the 1,000 times it gives me 1,000 times the right answer, then, well, it's reliable, right? And repeatable. Would there be other terms to use, or?
I would agree. So it is reliable, but I think also the term reliable would also kind of include robustness of an AI system. So as Sebastian was explaining, performance, it's about how well it basically performs the task, right? And there are different metrics like accuracy, precision, recall, and others. And robustness is more about how the AI system behaves on unseen input. So input they have never seen before, which was not part of the training material. So does it still act reliable? Does it still perform well, even if you have now inputs coming from a real world scenario, and the AI system has never seen this kind of input, like never seen this type of tree in a different light during the different time of the day, and it's still able to classify it as a tree, then it's also a robust system, basically.
Okay. Now I think I get it, but obviously I'm still not sure. But I think the explanations were very good indeed. So thank you very much for that. But there's also the concept of fairness. What is meant by that?
Yeah, so fairness is kind of, I mean, first of all, it's an ethical term, and it's also a kind of the main point with fairness is that usually intuitively one has an intuition about what is fair, but if you actually try to pin it down and make like a technical or mathematical definition, then you will find you can have like a wide range of definitions that often also contradict each other. But maybe still to say it a bit in general terms, fairness is like kind of means that your system is like non-discriminatory, and there are actually many cases, but maybe an intuitive case, let's say you have some system that takes in the data of people and decides whether they get a loan or whether they get admitted to a university, and then you kind of a fair system should not discriminate, for example, against different groups. And what this means, like for specific application, is like very context dependent, and also always a question of ethics.
Okay, but that also would suggest that the concept of fairness is not always applicable to an AI system, because I can see that an AI system might not be used to work with people's data, right? It also could be used to identify, I don't know, street signs, or it could be identified to do analysis of data of maintenance of, I don't know, generators. And would there be an application of fairness as well, or would that concept of fairness only be applicable to AI systems dealing with PII, personally identifiable information?
So there are systems where fairness does not play a role, but it's often not so easy as one would think to rule it out. So, for example, I'm sorry, there's some background noise. I hope you can still hear me. But
Yes.
If we come back to your example of street signs, that first seems like a neutral task. But let's say you're in a country where you have a lot of different languages, and you might have some minority languages, and then the street signs might be in that minority language. But maybe your system is trained on the majority language, and then if you kind of drive your car there, you suddenly have problems. And then suddenly we are back actually to a potential fairness problem that is intrinsically linked to a performance problem, because here our systems perform well in town A, in town B, but in town C it does not perform well. And that's not only a performance issue. In that case, it can also be a fairness issue. So I'm usually very conservative in saying there cannot be any fairness problems in that specific applications, even though there are. For example, if you're on a factory floor, like, I don't know, checking semiconductors with a camera, I now feel unable to come up with a potential fairness problem. But you really need to think kind of hard about it. Do we really not have any fairness issues?
Yeah, I think that is on a regular basis a serious challenge. A couple of years ago, I heard about a problem that sounded quite trivial, but was actually quite discriminatory, and it was the automatic soap dispensers in bathrooms. Well, they worked very well with people with white skin, but it didn't work well with people with darker skins, because somehow that light sensor was not calibrated sufficiently enough to identify the reflection coming from different skin colors. And obviously I can see this kind of applications getting more and more AI technology, and therefore obviously all of a sudden a very simple mundane primitive soap dispenser can have some kind of fairness issues. I truly see that coming. So would there be also any measures, for lack of a better word, that could be utilized to measure whether a system is fair or not?
Yes, there are, but the kind of the problem, or it's not a problem, it's just like an intrinsic fact with these things, is that there's a wide range of measures, because we have a wide range of definitions of fairness. So if we identify a potential fairness problem, we then need to basically ethically decide, okay, what do we consider as fair in this context? And if we have this, we can normally kind of write it down mathematically, and people have thought about this already a lot. There's a lot of publications and things available. And then we can kind of also measure on our AI system whether it is fair or not. But one also have to say one needs to be a bit careful with the wordings, and there's generally the trend to not say that our system is fair, but kind of that we try to make it fair, or kind of that it's less unfair, because there might also be other fairness problems that we have not thought about.
Right, yeah. Right. And so circling back to the original question or topic, so is there any difference? And if yes, what is the difference between performance and robustness?
Yes, there are kind of it's two things that are connected, but they are also different. So performance, as we had talked about before, basically means like how good our predictions are, kind of, and how accurate they are, in the lack of a better term. And how this is usually determined is, so usually we have some training data. Let's say if we come back to the street sign example, I think that's one that is very but easy to explain. We have a lot of images of street signs, and then we kind of label them hand by hand. This is a stop sign, and this is this type of sign, and this is tip. And then we train our model with it. And then we also have like a second data set that we have not used in training that also contains labeled street signs. And then we use our AI system, feed it with this new data, and see whether it can actually predict the labels correct. And then based on this, we can compute performance metrics, such as accuracy, recall, and the font score. There's also like a wide range. And
Okay.
kind of in the beginning of AI, and the notion was basically, okay, this is it. If these scores kind of are good enough, then our model performs well. But then it actually turned out that this is not always the case. And because like these AI models, they tend to be very complex. And in principle, one could hope, okay, one can ignore this. But people actually found, and also again with this street sign example, I think it was actually the first thing where people found this out, is that if you have such a trained AI model that is very good at predicting street signs, but if we have this model, and let's say we have a picture of a street sign and it correctly tells us it's a stop sign, it's possible to find very small perturbations in the image that maybe a human with the eye wouldn't even see. So we have image 1 and image 2, which basically look identical, but suddenly the model fails on this picture. And this is a robustness problem. And it's not...
What could be potential reasons for that?
It's not completely understood because the models are so complex. But still, there are kind of ways to mitigate this, because this is like robustness is again like a broad term, but kind of the most important one is this. This is also called adversarial robustness, where we kind of actively try to fool our AI system. And then what you can do, if you kind of know a way kind of to fool your system, you can include this in the training, and already when you train your AI classifier, you kind of include this kind of these perturbed examples, which are also called adversarial examples, and then you kind of help your system circumventing this problem. But kind of problematic, but also like very interesting thing is it's a bit a cat and mouse game, because in the training, all these potential attacks or ways to fool our system that we are aware about, we can use them in the training, and then the system will be robust against those attacks. But of course, what we kind of want that it's robust against like all kinds of things that could go wrong. And this is always a bit a cat and mouse game, because if then someone like finds a new way to fool your system, it might not be robust against this new attack.
So basically, clever people finding out that if you have an AI system which is not robust, you basically could exploit this and see this as a vulnerability and exploit it with cybersecurity attacks, right? This is where then try to create adversarial examples which look like correct input, but they have small perturbations which then completely flip the results. And then attackers try to create such samples so that to fool the system, and in order to counter it, you create the samples yourself, you train the system again, and then they are kind of robust against those attacks. But then basically another example pops up, and then the system might fool it again. So as Sebastian was saying, it's a cat and mouse game in this heavily researched field, and I think we are still in the early stage in order to really understand what we can do against those kind of attacks, instead of just creating examples, training again and training again. There are some fundamental questions we need to answer in order to really make some huge steps there and say, okay, now we have developed a new methodology which really helps us to counter all kinds of adversarial attacks against an AI model.
Yeah, I mean, coming back to that example of a street sign, let's say I see a speed limit sign, and I'm driving through obviously a residential area. What would be the probability that the speed limit is 250 miles an hour? or 250 kilometers an hour. So in other words, even if there is a sign that would say that, should the AI system not recognize that as obviously something totally impossible?
That's a very good and interesting point, where we also come to kind of a bit very current trend in AI, because like AI is kind of like the field is actually much older than many people are aware of. It kind of basically emerged in the 50s and 60s, and it came kind of in waves, and now we are kind of in a wave where we tend to base as much as possible on data. And in this speed sign context, this would mean we just get as much images and labels of speed sign as possible. But for example, in 90s, the approach was a bit different, and it was more, okay, no, we as humans think about like rules and boundary conditions. And in the 90s, it didn't work out really well for many applications for a wide variety of reasons. But what are people nowadays trying to do is still base it like mostly on the data, but also include these constraints. And this is actually a very good idea if you have something that's kind of detects street signs, and like kind of maybe like a very advanced system that really tries to read the letters and be like very generic. You still could impart kind of as constraint, but it cannot be higher than probably the highest speed level that is in the country you're in. So, and this is also one way to kind of to both make a system more performant, but also more robust, to include this kind of like realistic boundary conditions.
Mm-hmm.
And maybe also coming back to what Thomas last said, so we have this, like we tend to call it adversarial attacks, but it's not always kind of only a cybersecurity issue. So one thing, let's say you have a system that determines whether you get a loan from your bank, and you input your data, let's say where you live and your income and kind of all other things, and then you get rejected. But if you kind of know about enough the system, and if it's not robust, you might find a way that you very slightly kind of change your input values. Maybe you find out, okay, if I just have like €2 more income, and then suddenly I get the loan, then it's also a performance and a robustness problem, because then you kind of might be able to fool it again with like inputting like realistic data. Of course, if I tell it my income is 10 million a year, then it's clear I'm giving a false input and it's my fault. But if we're kind of in this gray zone,
maybe you are working just as a hobby.
Yeah.
I mean, there is a certain probability, right? I mean, it might be low, but I get it. Once again, it's this what is a limit that is reasonable, and what is a limit that is not possible, right? It's but obviously I can also see examples in medical applications where a picture is being used to determine whether there is cancer, whether there is a broken arm, or whatever, right? And all of a sudden, there should be some kind of limitations, I guess. But coming back to a slightly different question, and this is, so what is the impact if we have bad performance, or if the system is not robust? What could potentially happen?
I mean, a couple of things, right? So as Sebastian was saying, performance is kind of the core feature of an AI system. That's the first thing you're trying to achieve, that you say AI system is performant as possible. If it's not performant, then you might have misguided decisions, right? So the system doesn't perform as well, so it might give you wrong decisions. And if you use those decisions in further processing steps, then it can have quite a cascading effect as well. The other thing is, if you're not so robust, then it might be vulnerable to security vulnerabilities, to adversarial attacks, as we just mentioned, meaning that somebody could exploit the AI system, flip the outcome, etc. And together with all those things, basically also means it's kind of loss of trust in AI systems, since we are talking about trustworthiness of AI systems. And if your AI system and model is not performant as well enough, meaning that it does wrong decision, or it's open to security attacks, then people are less trusted less, and will not be eager to use this kind of system. And as a consequence, it comes down to economic loss. Obviously, if you're a company developing AI systems and you have issues in this area, those core properties of an AI system, then at the end it will cost you money. So it's really important features you need to invest in order to have a robust and a performant system. And as we discussed last time, also fair system. So all the properties we're discussing in a series of fireside chats, they are key in order to actually have a trustworthy AI system and have a trusted system people actually want to use and bring you economic value.
Yeah, and let's not forget, there's also the reputational risk, right?
Right.
So if an organization is using a system that is bad, well, not only are the users not using the system, there's also now that reflection upon the company that has introduced that system.
Mm-hmm.
And that is something that I think organizations cannot neglect, cannot ignore.
It might also put those legal implications, right? Which, if you see coming up regulations like the European AI Act, has important part is talking about accuracy and robustness. So if you are failing there and you basically falling under this regulation, then you have issues here as well.
Yeah, talking about the EU AI Act, that to the best of my knowledge is still not published as of today, although we have some kind of great ideas what it will contain. Are there any penalties associated with violations of the AI Act?
Good questions. I'm also looking forward to see the final version officially. First of all, what does the EU Act say about robustness and performance, basically? So there's Article 15, which focuses solely on those things. So basically, Article 15 is about accuracy, robustness, and cybersecurity. So here, performance, they use accuracy for the term performance we were using. And there, basically, a couple of points where if you are developing a high-risk system or using a high-risk system, you have certain obligations with respect to accuracy and robustness. So you need to make sure that you have achieved the appropriate level of accuracy, which is kind of vague term, right? It always has to be put in context of the use case and of the application. But it says there you need to make an accurate system, basically appropriate for your applications. It needs to be resilient against all kinds of attacks relating to robustness. So basically, the regulation will say you must do what makes sense and what is state of the art in terms of accuracy and robustness for your system if you are developing a high-risk applications, basically.
And maybe if I can add here, because the very special thing about like what we talk about today about performance and robustness is that this is really it's always important. So we discussed the like fairness issues a bit before, and we said it's often not easy to rule out that it's not an issue, but in some applications it's not an issue, and we do not need to consider fairness problems. But because if we had an application where we do not care about whether it's kind of performant or not performant at all, then I would say, okay, but then obviously we do not need this application, because if it just gives us random results, and I mean, there are things like we talked about the street science or medical applications where it's intuitively clear it needs to be very well performant, otherwise it's very dangerous. It might even lead to risk of lives. But even something that where nothing immediately happens, let's say some recommender systems that recommends you what song you might want to listen to next to. But if this is like this is not performant at all and it's basically just random, then still like it has like in the end it will have no value to you, and you also shouldn't use it. So you should, or like people will stop using it. So even if there's no like direct risk or danger involved, if you don't reach like the necessary level of performance, which in that case will be less, because if once in a while you will get a song that you do not like, of course nothing happens. It's not the same as in a medical detection algorithm, but still like it needs to be sufficiently performant. And this is a bit different to many other aspects that we have in AI and in trust in AI.
Right. But even there I can see some kind of challenges. You know, as we say, taste cannot be discussed, or preference cannot be discussed. But nonetheless, I even can see that in recommender systems, one or the other people might be offended by the suggestions they got in terms of the books they should read, or the clothes they should buy, or the songs they should listen to, for whatever reason, right? So I even can see there some extremes where such a system can be an issue. I would like to encourage the audience to put questions into the chat box so that we can answer those after our discussion, because we are looking forward to get feedback and questions from the audience. And I see there is one question that was posted by the audience, by one of the audience member, but it was also on my list of questions for the two gentlemen here. So I would like to read the question from the chat box from one of our listeners, and this is: how robustness of an AI application are demonstrated? How are robustness of AI systems, how can we demonstrate that this AI system is robust? And are there any examples of validated AI applications with reliable results used in regulatory testings and audits and inspection? This guy or this person seems to be coming from a tech industry company. Guys, any idea how we can answer that question?
So Sebastian, take the first part and I talk about the second part.
The first part I can answer. The second part, I'm afraid not. But so the first part, it's a difficult topic, but in principle, like kind of we discussed before, that robustness is broad and we have like all these potential different attacks and like ways to fool an AI system. And the current way is now to like you take your trained system and then you actually a bit similar to cybersecurity. You just try these attacks on your system. You see whether you can fool it. And if you do not manage to fool it, then it's robust. But we need to remember it's only robust to those ways of fooling it that we in principle know about. So we always need to be careful to say this system is completely robust. This we are not able to say, but we can say it's robust to kind of all the ways of robustness issues that we are aware at the moment. And for this, there are also like some software packages out there that are open source and that one can use to kind of to test one's AI system and also to incorporate this then in the end in the training to make it robust from beginning with.
Right. Regarding the second part, so I'm not aware of any good examples which have been validated in the TIC context or in the regulatory context, since this is all kind of fresh, right? And that's also leading to one of the things which we as a TIC industry, but also the industry itself needs to work on. There are standards in development and standards published. There's a standard on assessment of robustness of neural networks published by ISO. It's ISO 24029, so it's a technical report, not a standard, which gives you information around how you can actually assess the robustness of a system. But we have not yet a standardized way to reliable and repeatable test a specific AI system with predefined data in order to test its robustness and performance. That's something which is very application specific. So if you have a specific AI application with a specific AI model integrated in a specific context based on very specific data, obviously, then you need to look at this application. I don't believe there will be a general set of data you can utilize for all kinds of things, obviously, because the AI models are quite different. The data there was used to training is different. But this is also will be always very application specific and very context specific in terms of accuracy or performance and robustness testing.
So the next thing I see here in the chat box coming from the audience is not necessarily a question, but more a statement, but still leading to a question. And this is need for clear definition or definitions of different types of robustness. Are there different types of robustness? And if yes, would there be different definitions available?
Yes, so there are many different types of robustness. So the one I mainly talked about today is this adversarial robustness, but there are also many others that are really important. For example, there's robustness against noise in training data, which is kind of a bit different thing. There's also robustness to random perturbations, where the issue is not that we deliberately try to fool our AI system, but let's say we work with camera data and we train it with one camera, and then we use another one that maybe has a slightly different noise in the images. And it might be that then our system suddenly fails because it's not robust kind of against this new noise in the camera. And there are different definitions, but they at the moment mainly come from the scientific literature, and there it's kind of always a bit inherent. It's not completely standardized. So I'm not aware of any standard that really like clearly defines those different types of robustness. So one needs to be at the moment a bit careful of what those terms really mean, and also whether like all the scientific literature and all the tools available really kind of are talking exactly about the same thing.
Okay. So from your point of view, what are the biggest challenges in the field?
So I think here we need to, again, like differentiate between performance on robustness, because performance is also a bit special compared to many other issues around AI, that in principle, the way to measure it is not so complicated, and it's very well established because it's not actually AI specific. It's something, for example, that happens in traditional statistics in all kinds of different mathematical models. So the way to measure it is not so difficult, but the question on let me rephrase it like this. So there are many metrics around that are well established, like accuracy, precision, recall, and it's not hard actually to calculate them based on your application. But choosing which one is actually relevant is much less straightforward, and is again very application and context dependent. And even though this is that's daily business of data scientists, AI developers, and statisticians, still, like if you then have a real world applications, it's usually not so straightforward to say, okay, this is really the metric we need, and then also this is like the level we should reach. That's even harder. And so I think in terms of performance, this is the biggest challenge. And in terms of robustness, it's different because they are the way to measure it. So we already said there are ways to measure it, but like there are different definitions, new robustness problems could come up. So there I still see the actual challenge of really finding reliable ways of measuring robustness.
Okay.
All right. I would also like to add, yeah, so two things maybe. On the cybersecurity side, there's a lot of research around the security of AI systems and adversarial attacks, or how we actually can generalize those concepts and make really develop methodologies which are applicable in general to secure AI systems against those kind of attacks. And then also kind of the scalability. So we see that especially obviously in large language models, we are talking about huge models with huge parameter sizes. So how performance and robustness basically, or how we can maintain performance and robustness in scale when models are getting bigger and bigger, and the data sets are growing in size and complexity, that's also quite challenging.
Okay. So looking at the crystal ball, what do you guys see happening in the near future? As in the next couple of months, in the next, I don't know, 3 quarters, in next year?
Sebastian?
That's a tricky question. So maybe to answer like specific for today's topic, what I definitely see is coming, that we will probably find more robustness issues with AI applications, both with I call it now traditional applications where we train it on a specific data set and then use it something. And then also for this, like at the moment, very important large language models, where all these things are still a bit in the infancy. So if you would ask me now, okay, you use ChatGPT or some other large language models for this purpose, and Sebastian, can you test for me whether it's robust? Then I would probably have to say, no, probably I can't, because this is a problem that people are aware of, but that definitely is not solved yet at the moment. But I'm confident that these people will work a lot this in the next months, but maybe it will also take years.
I would add, obviously, coming back to security as well. So I see there will be a lot of advancements in adversarial defense techniques. So there is a lot of research and time and money invested in how to defend against those attacks on AI systems. And I also think there will be a lot of innovations around AI testing and evaluation now, with the new regulatory frameworks, with new pressure on the industry and on the tech industry as well to evaluate the AI system. We will see new methodology and new tools being developed, which allows us to more reliable and more comparable test AI systems against robustness and and performance in all kinds of different scenarios.
Okay. So there are two more questions in the chat that I would like to share with you guys and post to you guys. So the first question is, which is the current with the current wave in AI technology, which business areas is the most, in your opinion, is the most advanced in using AI adaptation? So in other words, from your perspective, from your point of view, what is the kind of industry that is most advanced in using AI?
Difficult questions. Not deep into all the industries. I would say definitely in pharmaceutical industry or pharmacy and medical, there is a lot of development for medical, basically in imaging, so MRI scans and stuff like that, because this is a research field which is around for many years, where people were starting to use machine learning to classify images to detect the diseases in images. So this is all a lot of many years already have been spent in developing AI system in this area. In the pharma industry as well, for drug development, etc. I see probably they are using those kinds of tools for much longer than other industries. I also think that in industrial, in robotics, there's a lot of AI advancements. There's definitely no industry which is not affected by AI systems or by AI models, or there's no industry which there's no use case for this kind of things. But off top of my head, I would say those things are pretty advanced.
Yeah, and from my perspective, it's the obvious that is not obvious. And what I mean by that is, sorry, my Word and my Excel applications are using AI. Sorry, when I go to my favorite music store for listening some songs, there is AI involved. When I go to my shopping cart in an online shopping company, there is AI involved. So what I'm trying to say is AI is creeping in on everything we do, and it's so pervasive that we don't even notice it. It's there, it's right in front of our eyes, and we don't realize it. And then the very last question from the audience, and then we are coming to an end. The very last question or comment is, does the integration of additional fairness-related features in an AI system entail a trade-off with its robustness? And if so, how does this trade-off manifest itself in practical applications?
Yes, so that's usually if we deal with performance or robustness on the one hand, and then with fairness on the other hand, we have these trade-offs, and between fairness and performance, it's usually also intuitively to understand. With robustness, it's a bit more tricky, but I mean, at least intuitively to say, because if we also include like fairness-related features, so also fairness constraints, then we add like another level of complexity, and we also have therefore another level where things can, without our knowledge, suddenly be not robust. So let's say we have a system that we deem robust, and then we also kind of try to make it fair. Then we cannot assume that it's still robust in the same way, and we at least have to check it again. And it might be that like for example, the fairness constraints we included, that they lead to some robustness issues.
Okay, excellent. Well, gentlemen, some last final words from you, or should we just wrap it up and say thank you very much to the audience?
Thanks everyone for listening. If there are more questions, feel free to reach out to us. Happy to answer them all.
Yes, for me also. Thanks as well. It was very nice.
Thank you so much. And for the benefit of the audience, as you may know, as you obviously know, this was the second fireside chat. And in the next coming month, we will have several more coming, and they are all being on LinkedIn Live. So please stay tuned and watch out for further announcements, and looking forward to welcome you again next month on our next fireside chat. Take care and bye-bye.